Okay, let's do some examples practicing our counting techniques. So to do that, I have, let's say, a lock that inputs 4 digits, each digit taking on values between 0 and 9. So there are 10 different options in terms of numbers. So that's kind of what this lock represents. You would put in 1 digit here, 1 digit here, here, and here. So 4 digits to create a 4-digit lock code. So 0 through 9 in each of these 4 spots. So if you want, you can pause the video and try some of these. So my first question is just how many unique lock codes can we create? And then part B is what's the probability that the first digit would be even? Even would include 0, so there are 5 options for even digits. Part C, what's the probability both the first and the last digit is even? And then D, how many unique lock codes are there if we can't repeat any digit? So if you got, say, the digit 2 here, then 2 cannot be used here, here, or here. And then finally, this isn't really the lock question, but I'm just asking how many ways can we pick or select 4 numbers from 10 unique digits? So if you want to try these, go ahead and pause the video and see what you can do. But I'm going to get started on these. Okay, so part A, how many unique lock codes can we make? Okay, well, I'm going to just do this piece by piece. So how many options do I have for that first digit? And there are 10 digits, so I have 10 options for that first input. Second digit, well, again, I still have 10 options. Third digit, still have 10 options. And fourth digit, I still have 10 options. I can use 0 through 9 in any of those 4 spots. Right, there are 10 digits for each spot. So when I calculate this, using our basic counting principle, so I have 10 options for the first, 10 options for the second, 10 options for the third, and 10 options for the fourth. So this is equal to 10 to the fourth, which would be 10,000. Okay, part B, very similar, but that first digit needs to be even, and there are 5 even numbers, 0, 2, 4, 6, and 8. So now I only have 5 options for this first digit, but there are no restrictions on the second, third, or fourth. So I still have 10 options here, 10 options here, and 10 options here. And so that means I have 5 times 10 times 10 times 10 is equal to 5,000 unique codes where the first digit is even. So when we think about the probability of, probability first digit is even. So there are 5,000 unique codes where the first digit is even. And then we found in part A that there are 10,000 total lock codes. And so this would just be equal to 1/2 or 50%. There's a 50% chance that that first digit is going to be even. Okay, but what if both the first and the last digit has to be even? Okay, well, so that means we have 5 options for the first, no restrictions on the second or third, so 10 total options, and then 5 options for the fourth digit. So I have 5 times 10 times 10 times 5. That's how many ways we can create a unique lock code with both the first and the last digit is even. And I'll just go ahead and divide this by the total number of lock codes, which is 10,000. And so this will be equal to 2,500 over 10,000, which is 1/4 or 25%. Okay, how many unique lock codes can we have if no digit can be repeated? Okay, well, the first digit, there are no restrictions. We still have all 10 unique digits to pick from. But then for our second input, we only have 9 options to choose from. Right? If we can use 0 through 9 for that first input, let's say we use the number 9, well, then we're limited So we have 0 through 9 here. Let's say we used the value 9 in the first spot, so that means we only have 0 through 8 left. And then we would only have 8 options for the third and 7 options for the second. So this would be equal to 10 times 9 times 8 times 7 is 5,040. But we also could have recognized this as a permutation because we're trying to order 4 digits from a set of 10. So we could say alternatively, since order matters, we could call this a permutation where n here is 10, p 4. How many ways can we take 4 from a set of 10 and create unique arrangements? So this would be equal to 10 factorial over 10 minus 4 factorial, which would be 10 factorial over 6 factorial. So this would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times 5 times 4 times 3 times 2 times 1. So I'm going to cancel all of this, which leaves me just with 10 times 9 times 8 times 7, which is equal to 5,040. And then finally, how many ways can we select 4 numbers from 10 digits? So here, like I said, I'm not trying to create unique lock codes. I'm not ordering anything, so order does not matter here. I'm just saying select 4 from this group of 10. So this would be a combination, so 10C4, or we could write that as 10 choose 4, which is equal to 10 factorial over 4 factorial 10 minus 4 factorial. So that would be 10 factorial, 4 factorial, 6 factorial. So we have 10 times 9 times 8 times 7 times 6 times 5 times 4, 3, 2, and 1. And then I have a 4, 3, 2, and a 1. And then I have a 6 and a 5 and a 4 and a 3 and a 2 and a 1. So just before, I'm going to cancel D6 with D6. The 1 doesn't matter. I'm going to cancel this 4 and 2 with the 8 because 4 and 2 makes 8. And I'm going to cancel this 3 with this 9, which will give me a 3. So this leaves me with 10 times 3 times 7, which is equal to 210.